Okay, so welcome back to Mrs. Riley's Maths videos, and this is my third video on surds. And what I'm going to look at today is I'm looking at multiplying surds, including compound surds. I'll explain what those are in a minute, and dividing surds. So we're starting off by talking about multiplying surds, and the main thing is we've looked at this already a little bit when we looked at the rules of surds, just this idea of a compound surd, which is what we're going to look at in a little while, where you've got two. Well, let's look at this. This is a compound surd here. These are compound surds where we have two surds added together, or where things are added together. So we're going to look at those now. They're not as bad as they look. It's kind of basic algebraic multiplying of terms. So if you're good at that, you shouldn't struggle too much with this. Just when we come to talk about multiplying surds, just to review a bit of terminology, or maybe introduce a bit of terminology, this number here that doesn't have a square root is called a rational number. So it's the rational part of the surd. And this here that does have the square root is called the irrational part of the surd, or the irrational number. Okay, so that's a word I'm going to be using as we talk about the rational and the irrational. So just listen out for that and hopefully understand what I mean. In this case, we've got root 5 by root 6, which hopefully you'll know at this stage means we've got the square root of 5 times 6, which is the square root of 30. Now, in these examples and in all our exercises on this, you've got to remember that we always give the simplest form of the answer. Sometimes it actually helps to simplify at the start, and sometimes it helps to simplify in the middle, and sometimes it helps to simplify in the end. So just keep an eye open along the way of what's going to make most sense. In this case, I have the square root of 30. I can't think of a way that I could simplify that, so the answer is just going to be the square root of 30. Now we have 3 root 5 times 4 root 2. What I'm going to do here is I'm going to deal with the rational parts first. So 3 by 4 is 12, and then the irrational parts would be root 5 by root 2, which would be the square root of 10. So I have the square root, I have 12 by the square root of 10. Again, I don't think I can do anything with that. I think it would be complicating things to try and reduce it any further. 3 root 7 by 5 root 7. So it's going to be 3 by 5, which is 15. Root 7 by root 7, of course, is going to be 7. We could go down this way and say it's 15 by the square root of 49, 15 by 7. Anyway, 15 by 7, which is 105. So 3 root 7 by 5 root 7 is 105. 3 root 5 by 2 root 6. So 3 by 2 is 6. Root 5 by root 6, we found out up here, is root 30. Root 5 by root 20 by root 2. Well, as you know, when you multiply things, you take 2 at a time. So let's take these two together. That's the square root of 100 by the square root of 2. So, of course, that's 10 root 2. 2 root 5 by root 2. Well, there's kind of a 1 in front of that, but we can't see it. So 2 root 5 by root 2 will be root 10. Minus 2 root 5, so I did this by this, so this is where our algebra comes in. Now it's going to be this whole thing by minus root 5, so minus 2 by root 5 by 5, so root 25. So it's 2 root 10 minus 2 by 5, so 2 root 10 minus 10. I suppose if we wanted to, we could mess about with that, but I actually don't see the benefit, so let's just leave it as it is. 5 plus root 2 by 5 minus root 2. So again, this is linking back to our algebra. How do we multiply this out? We've got a compound surd. So this is what I meant by a compound surd. Well, actually, these are rational numbers, so it's not really a compound surd, but it is a compound surd over here, really. Anyway, you get the idea, just where it's a bit more complicated. In this case, I've got these two terms in this are multiplying by these two terms in this. So again, slowly, 5 by 5 is 25. 5 by minus root 2 is minus 5 root 2. Root 2 by plus 5 is plus 5 root 2. And root 2 by minus root 2 is minus root 4. So I have 25. Now this is interesting, and it will come up again later on when you're dealing with surds. If you notice here, minus 5 root 2 and plus 5 root 2 will cancel each other out. They're the same thing, except one is negative and one is positive. So they're going to cancel. And minus root 4 is just minus 2. So actually my answer to this very complicated looking product is a rational number, because the irrational parts cancel each other out. And we use that later on when we come to do division of surds, more challenging division of surds. Root 12 by root 75. I have an idea I might find it easier to simplify these a bit first. So let's try it two different ways, okay? Let's try it as it is. So 12 by 75 is 300, I think, isn't it? 12 by 75, no. 12 by 75 isn't 300. 12 by 75 is 900, is the square root of 900, and actually the square root of 900 is 30. So that works out very nicely. If I was to do that a different way, root 12 by root 75, well, I might see here that root 12 is actually the square root of 4 by 3, and 75 is the square root of 25 by 3. So what I would have would be 2 root 3 times 5 root 3, which would be 10 by root 9, which would be 10 by 3, which would be 30. Now obviously this is much more cumbersome than this, but this I suppose requires you to know what the square root of 900 is, which might be harder for you. Okay, anyway, this is no harm to practice, so we could see how it would work out. 4 root 2 by root 8 plus root 2. So here's definitely a compound surd here, two surds added together. So I'm multiplying 4 root 2 by root 8. So that's going to be 4 root 16 plus 4 root 4. That was 4 root 2 by root 2. So 4 root 2 by root 8, the 4 stays as it is, the rational number. The irrational numbers multiplied together gives me root 16. And then here, 4 root 2 by root 2, the rational number stays as it is. Root 2 by root 2 gives me root 4. So what do I have? I have 4 by 4 plus 4 by 2, which is 16, plus 8, which is 24. So again, a very nasty looking compound surd multiplied by another surd actually gives me a nice answer of just plus 24. I'll look back over there those now, and then we'll move on to division. Okay, these next questions are about dividing surds or division of surds, and just before we do them I want to remind you of something. If I had 5 and I was to multiply it by 2 over 2, what would I get? I'd get 5 times 2, which is 10, over 2, which is 5. Okay, why is that? It's because multiplying something by 2 over 2 is just the same as multiplying it by 1, which of course means we get the original number. So this idea of being able to multiply something above and below by the same number and not changing it in any way is the basis of what we do now when we divide surds. So let's take this first example here and see whether it'll make more sense as I work through it. Here I've got 4 divided by root 2. And what I want is I want to be able to write this. So, sorry, I just was interrupted there. 4 root 2 divided by, 4 divided by root 2. So what I want to think of is there something that I could multiply this fraction by? It would have to be the same thing on top and on the bottom, so that I got 1, like up here. Is there something I can multiply this fraction by that would what's called rationalize? Oh yeah, that's what I was talking about. Rationalize the denominator. So let's just do a quick refresher on what that phrase means. This here is the denominator. If you remember, when we have a fraction, we have a numerator and a denominator. This is the numerator. This is the denominator. To rationalize the denominator means make the denominator into a rational number. So we want to make this denominator into a rational number. So what could I multiply by root 2 that would make it into a rational number? And hopefully you can see that what I would multiply it by is I'd multiply it by itself in this case, because root 2 times root 2, well, root 2 times root 2 is root 4, which is 2. So root 2 times root 2 is the square root of 4, which is 2. And then on top I would have 4 root 2. And my answer, in fact, then this could divide into this, couldn't it? My answer would be 2 root 2. Okay, let's try the next one. Root 5 divided by root 3. Well, I'm going to multiply above and below there again by root 3. Because root 3 by root 3 will give me the square root of 9, which is 3. Root 5 by root 3 will give me root 15. So root 15 over 3 will be the answer to that one. Okay, and that's all I can do. I can't do anything else with that. 15 over 2 root 3. Well, what would make 2 root 3 into a rational number? I can kind of ignore the 2. If I just multiply both sides, top and bottom, the numerator and the denominator, by root 3, because that's the only bit that's really causing any trouble. So on top I'll have the square root of 15 by 3, which is the square root of 45. And here I'll have underneath I'll have 2. Root 3 by root 3 is 3. So I'll have 2 by 3. So what I have is root 45 over 6. Now actually root 45, if you remember, I can actually split root 45 into root 9 by root 5 over 6. So what would that give me? That would give me 3 root 5 over 6, which would actually cancel down to be root 5 over 2, because 3 cancels into 6 twice.